So first I want to give a little background. Basically it's this idea that the scholarly article as a standalone publication is starting to fade quite quickly. So there's a lot of granting institutions now want you to share your data along with the article. Also, some people are sharing code in platforms like GitHub, and a lot of the time these components are all in separate repositories and not all in one place. So on top of that, there's some movement towards recognizing other people who contributed to projects, not necessarily just the authors of an article. And a lot of the time on these projects, there's many roles involved and many people that contributed. So what we're looking at here is quite a broad map of resources, all with different relationships to one another. And many of these things in this diagram wouldn't have a unique identifier like a DOI or an ORCID. So a lot of the time these maps don't already exist in one place. So I'm going to show you some examples of discos that we've created in our map so far that demonstrate how you can combine this data as linked data and get a broader map of one object. So in this case we're going to show 3 different discos that all relate to one article, the one circled in green. So this first disco I'm going to show you relates to an import from DataCite, and at the middle of this map is a code set that was in DataCite, and it shows you some information about that code, including who created it, some other citations for the code, versions, and also pointing back to the article. So before we look at the actual diagram, I just want to show you what's in a disco. So first of all, there's a unique persistent identifier for a disco that can be used to get your disco back later. There's a creator, which in this case was a harvesting tool, but it could be a person. You also define a list of aggregated resources. In this case, we're just defining one code set as an aggregated resource, but you can have multiple objects here, and then they're treated as a compound object. And then what you can do is say as many assertions about those resources as you like. But the one rule is all of the assertions must form a connected graph in the system. So later we'll see examples where you've got more than one resource, and then a list of statements about each of those resources as well. So let's take a look at the visualization. So you can see here that in the middle is the code, that's the orange circle, and it has some 3 creators here. These are the red circles. And then you can also see that there are other identifiers. This is where it points to the article that was circled in the diagram. The code is a supplement of that article. You can also see a link to another version of the code here, and some other website links for coming out of this code set. Discos that describe this resource or mention it. There's a whole list of the statements as text here, but we'll look at the diagram. So now you'll see that this article has a lot of metadata about it, and a lot of it is text-based metadata, things like keywords. You'll see a title over here. So these gray dots don't link out to anything, they're just strings of text. So if I switch those off for a second, you can see that all of these are URIs that connect to this one article. So we have 3 different code sets here, that's the orange circles. We have some creators listed. We also have some citations out here. And you can see that combining these 3 discos creates this much more complex view of the one article. So you can also navigate through and click on these to see more information about each of these objects. So if I go to this one, you can see what we now know about this piece of software, which is it has these 3 creators. some abstract information. It has versions over here and over here, and that it cites that article. So what I've shown you is what happens if you combine 3 discos about one article, and how you can then get this rich data set that you can navigate through visually. The feature I wanted to point out about discos is that you can version discos. So if you need to do some updates to the disco, or there's errors, or you want to add something, then you can just create a new version of the disco. But in our system, unless you delete something specifically because of a privacy reason or some other reason, then that disco will not go away. It will just become inactive. And the purpose of this is so that when you get a unique identifier, you can always get back to that original set of statements that were inferred at the time of that identifier's creation. There's ways in the system that you can move to the latest version if you want the latest version of a disco, but you can always get back to that specific version from that moment in time. So on here you'll see that this disco is marked as active in the top right, but you'll also see that there's some other versions of discos down here. So if we go to those, you can see these ones are inactive. So they're still available, they're just marked as inactive. And you'll see some events here. I'll just show you what one of those looks like. So an event contains the system user that initiated it, a start time and an end time, what was the target of the event, what happened, and what resources were affected by the event.